Alright, a little lesson on how to subnet. Now, before we start, you need to know binary to decimal conversion. You need to know, and vice versa, you need to know, how to do it both ways, decimal to binary, binary to decimal. Okay, the second thing I want you to know is to read Cisco's description on how to subnet using the 2 to the n formula with a calculator. Once you have that mastered, come watch this video. Okay, now we have a network of 192.168.1.0, and we need to subnet these. We need to figure out the subnet mask is what I'll be doing. One network needs 29 hosts, and another network needs 64 hosts. Okay, now automatically I know in the last octet gives us 200, goes 2 to the 8th. Now this is one I do memorize. I don't know how to, I don't actually do the math in my head. I just memorize that 2 to the 8th is 256. I feel like that's a very good one to just memorize in your head. And you also have to subtract 2 since we're dealing with hosts, so we have really 254 usable hosts. Remember, because you can't use the broadcast address and you can't use the network address. Okay, so automatically I know right there that I am going to be subnetting this down to 255.255.255.something. And to find out that something, I'm going to start writing out the binary placeholders. Um, 16, 8, 4, 2, and 1. Okay, now Cisco tells you 2 to the n. Okay, well, let's say if you only borrowed 1 bit. What's 2 to the 1 bit? This is 1 bit. If you turn just this on, well, it's 2, right? Here's the second bit. If you turn this on, guess what? You get 4. If you turn this on, 2 to the third, guess what? You get 8. Okay? Now, what are we doing here? Get the pattern? We're doubling here, starting with 1. Here, we're beginning with 2, and we're doubling. All you do is just keep doubling. 16. Okay, still not to 29. Remember, we have to subtract 2 since we're dealing with hosts. This will be 32. 32 minus 2 is 30, which is indeed greater than 29. Okay, so this is where our last 0 is. Remember, we're dealing with hosts, so these are all host bits. Okay, at the place that we stop. This is where the network bits begin, going from right to left. Okay? These will all be 1s for network or subnet work. Okay, now in order to find out the subnet mask, all you do is you take the 1s that are turned on and you add them up. So 128, 64, 32. There's 10 and 12. Carry the 1 is 3, 9, and 12. And did I do this right? No. That should be a 4. Okay. And we should have carried over a... No, we carried a 1. That's correct. Yeah. And we carry another 1, and we're going to get 224. Okay, so 128 plus 64 plus 32 is 224, which I knew already. That's why I knew I made a mistake. I have all those memorized. Okay, so our subnet mask for this network will be 255.255.224. Okay, now 64 hosts. Okay, same thing. write out our subnet mask. We know that we can fit this in the last octet because 254 is greater than 64. So 255 255 dot. Now we need to write our binary placeholders. Eight, 4, 2, and 1. Okay, now start from 2 and double. Dummy. 64 there. And remember, we have to subtract 2. 64 minus 2 is 62. That is less than 64, so we need to go one more. Up to 128. This actually gives you 126 usable hosts. Because you can't use the subnetwork address and you can't use the broadcast subnetwork address. So, our last 0 will be right here. These will all be zeros. And this will be a 1. So this one was easy. 128. Okay, and 128. Now, if we need to write this in CIDR notation, well, it's really easy. You know, this is 24, 3 255s. Each 255 is 8. 8, 16, 24, 25, 26, 27. So, this is a /27. This would be a /25. Because we have 24 here, and there's the 25th bit. So, that is all there is to subnetting. Now, a few other things I want to point out. If for some reason we had a Class B network or a Class A, let's just say it's Class B, 16.1.0, so we got a 16 here, and we need, let's say, 1,000 hosts. Okay, what we would do then is automatically, I know right here is 256. Now you can start with 2 and keep and go all the way up to here, but you will notice that you will get 256 when you keep adding up. So I would automatically remember that the last one in the 4th octet is 256. Okay, now going further, 512 beginning in the 3rd octet. The next one's 1024. Minus 2 is 1022. That is greater than 1,000. So that is where our last 0 will stop. We will have 2 zeros there. And 8, so there'll be 10 zeros total. The rest will all be turned on. And I can tell you right now that is a 252. If you add all these up, 1, 2, 3, 4, 5, 6. That's 8 right there. So if you add 128, 64, 32, 16, 8, and 4, you will get 252. And that is how this works. This does not reset like the binary values do. This is in the 1's place in the 3rd octet. This is in the 2's place in the 3rd octet, and etc. These numbers here, where I'm doing 2 to the n, and that's basically what this is, 2 to the n. Numbers do not reset. Okay, now, if it says, for some reason, 64 networks instead of hosts, well, again, we know that the 4th octet allows for 256 possible networks to the 8th, right? Going from left to right instead of right to left. Okay, so they're all going to be 255s again. This time, we will start with 2 at our boundary. and we will go double here. 4, 8, 16. So 2, 4, 8, 16, 32, 64. This time we do not have to subtract 2 unless it specifically tells you cannot use subnet 0. So then all you do, this is where our 1 is going to be, not 0 this time because we're dealing with networks. So this is where our 1 will be. And again, we add those binary values up. Whatever that turns out to be will be our subnet mask, and I can tell you right now that that will be a 248. 128, 64, 32, 16, and 8 equals 248. Okay? And that's all there is to it. If this somehow were a class B, we would start with the we would actually do the same thing I just did here, only we'd be beginning in the third octet for networks for subnetting a class B. Class A, you start in the second octet because these are all reserved. The first 8 bits are all reserved. So you start in the second octet for a class A and define 64 networks. You just start with 2 and double from left to right. It's as simple as that.